Okay, now the next part of this is, as we can see here, that rotation motion. Okay, rotation is a system of particle rotation. Like, just brief idea. As you can see here, it is rotating. Now, in the rotation, remember the most important thing will be axis of rotation. How it is rotating. Like even the Earth is rotating, right? About its own axis. The axis is slightly like this, some angle with north and south, but it is spinning. So rotation is there. Similarly, sun, around the sun, revolution is also there. So two type of motion Earth is performing. Okay. So whenever there is a rotation, the most important thing will be there will be some axis of rotation. Means about which line it will rotate. What is rotation basically? If you'll see, the rotation is nothing but the extended form of circular motion. Extended form of circular motion. What is circular motion? We already discussed in previous class. If any object is moving, right? Any object is moving about a center, then we'll say it is a circular motion. So it is moving in a circular motion, right? This object is moving in a circular motion. So single object will say about circular motion. Suppose it is a full object, not just a single object, some big object. Then we'll say object is rotating about C and passing through one line perpendicular to its plane, that will called as axis of rotation. So that again we'll discuss after this, completing this entire center of mass concept. So let's see the slide. Consider a solid sphere rolling down an inclined plane. Now, can anyone tell what the difference between inclined plane and wedge? Already maybe I told so many times. What is the difference between an inclined plane and wedge? This is inclined plane, right? What's the difference between inclined plane and wedge? The minute difference is there. Anyone knows about it? Okay. The minute difference is, remember, inclined plane is a fixed surface. Wedge can move as per the requirement of the question. Like for example, suppose on a wedge, in fact, this is what we are going to discuss, the theory. Suppose it is frictionless, everything is frictionless, and the block is moving in this direction, downward. Wedge will start moving in the backward direction. This is related with center of mass concept we are going to discuss. So when it is moving down the slide, down the inclined plane, wedge will start moving in the backward direction. That observation you can do, provided everything is frictionless. Friction should not try to resist somewhere surface and all those things, right? So inclined plane, remember, is a fixed thing on a surface. Inclined plane cannot move. Wedge, on the other hand, can move on the surface. Okay. So this is a small minute difference you have to remember. Now consider a solid sphere rolling down on the inclined plane. Sphere shift from the top to the bottom, and inclined plane has a translational motion. Now translational motion. For the translational motion, remember, we will consider this center of mass. Just consider center of mass. It was here initially, then it was here, then it was here, then it was here, then it was here, then it is here, right? Then it is here, finally it is. So center of mass. Okay. So we'll say that center of mass is performing translational motion. Object is performing rotational motion. This is combined motion. Remember, now three type of motion you have to understand. One is translation. Translation. Second is rotational. Third is combined motion. Okay, if you'll see JEE advanced level problem, combined motion more it will be asked. NEET level, rotation topic, generally they will ask this one. Sometimes combined motion they can ask you, but they try not to ask combined motion because conversion of momentum and all those things slightly complicated. So translational and rotational will be generally favorite topic for NEET. Combined motion, some basic questions can be asked in NEET. But in JEE advanced level, combined motion is the favorite topic in rotation. So we have to do the combined motion also. This is combined motion. So first thing everyone should understand to identify the motion, which motion we are talking, whether we are talking about translational motion, whether we talk about rotation or we are talking about combined motion. So first identification of motion has to be there. What type of motion we are having. Now in the rotational motion, all particle will not move at in same velocity at any point of time. Why? Why it will not move?
Sure,
because yeah, because there is a translational velocity, which we say as velocity of center of mass. So this translational velocity, each and every object, each and every point of the object will be have. Try to understand. Now this is a minute thing, this is a very important thing you have to understand. It will again come in rotation, but since point is there, I'm explaining you. VCM, velocity of center of mass, will be for each and every point. Other than this, it is rotating also. Now if you remember in circular motion also we discussed, if anything is rotating about any point, there will be a tangential speed. So that will be R omega. So R omega direction at the topmost point will be like this. But the bottommost point R omega will be like this. At this particular point, R omega will be like this. Right? So different point, R omega direction is different because of rotation. Tangential speed is different. And when we take the vector sum of R omega and VCM, it will come different. That's what we are saying, that all particles are not moving in the same velocity at any instant of time, because rotational motion also has to be counted in that. So that is what we are going to discuss in detail in rotation when we discuss. Okay. So this object is in a combined motion. It is not pure translational. Okay. It is a sum of translational and something else, which is called rotation. Okay. The body, the line along which the body rotates is termed as axis of rotation. Okay. Now see it here. 1 second. Let me show you the animation. Okay, let's go back to that. Okay, this line, right? This line is axis of rotation. About axis of rotation only, object is rotating. For the Earth, try to understand. I think Earth you will understand better. You know that North Pole and South Pole, one axis is there. Not exactly, slightly it is towards this one, but North and South, right? Axis is there. So spinning motion is there. What direction Earth is rotating? Tell me, east to west or west to east?
West to east.
West to east. How we know? Can you prove it logically? Okay, what direction sun is? We are feeling sun is rotating. We are feeling, that is incorrect basically. But what direction sun? In the morning, what side it is?
East to west, sir.
East to west. We are feeling the sun is going from east to west. So basically sun is at rest relatively, as in Newtonian physics, according to Newtonian physics. So it is moving from east to west. So Earth is basically going from what direction?
West to east.
Yes, west to east. Okay, the rotation is west to east. That's what we are feeling the sun to be moving from east to west. Okay, which is basically our relative observation. Like something in the platform, when the train is moving, what we feel that platform is moving the backward direction. That is our observation. But we know that train is moving basically in forward direction, but we observe platform is moving in backward direction. So using that logic, we can find sun's rotation. Okay, now let's go to the next thing. Focus is to today's center of mass. Okay, focus is today's center of mass. Okay, now here, can you do this magic? Can you balance it?
Yes, sir.
Yes, how it is happening basically. This is a very good example to understand center of mass. How it is happening.
Sir, the equal mass balance system.
Yeah, what is this point?
Center of mass.
Yes, this point is nothing but center of mass. Now, one thing you have to understand, center of mass is a hypothetical point. Meaning of that what? Suppose someone is taking one scale and he's telling, sir, center of mass is here. So all the mass is here. Can we remove this part and just can we go and find mass M? So answer is no. So center of mass is a hypothetical point basically, right? It is a hypothetical point at which entire mass is supposed to be concentrated. And to explain certain phenomena in physics, we are using center of mass concept, but not all. Again, not all. Like moment of inertia calculation in rotation, we cannot replace the object by center of mass. So if you'll replace object by center of mass, it will not be correct in calculation of moment of inertia. That we'll discuss it. Okay. So here, this is okay. Center of mass is a hypothetical point, and this phenomena will be explained by center of mass. Similarly, some more examples are there. Okay, so these things we have to understand. So you can see here now when we throw something, it's a combination of translational and rotation motion. Now where the center of mass is coming into picture here, center of mass is basically performing translational motion. Here only it is related. So if you'll see this object, when we draw the path, even when we have drawn the path of a projectile, which point we have taken basically? We have taken center of mass. We concentrate on center of mass because that is a hypothetical point. We can assume that entire mass is there. Okay. The point which has a fixed path of motion is called center of mass. Okay. So in this way also in rotation, when we go, when object is rotating, when we are talking about translational as well as rotation, then we have to concentrate on center of mass. The point which has a fixed path of motion is called center of mass. Even suppose one sphere is there on a surface, like billiards table, right? In billiards in fact is the best example to understand rotation topic. Okay. So object is, the sphere is moving as well as rotating. So different point is a different position, but if you see the center C, this will always move in a straight line. It will not rotate. Center C is always in the straight line. So that's what the point which has a fixed path of motion is called center of mass. Okay. So center of mass is a hypothetical point at which entire mass is supposed to be concentrated, and it is used to explain certain phenomena in physics, and which will have a fixed path of motion even in a combined motion. Even in a combined motion. Combined motion means when translational and rotational are combined together. Okay. So any doubt, anyone in this? So instead of studying all the point, we'll study only the center of mass and consider the body as a point mass. So how it is defined? Center of mass is defined as the point at which the whole body of the whole mass of the body is supposed to be concentrated in order to study the motion of the body due to external force in accordance with Newton's laws of motion. Now, center of mass and center of gravity, is it same or different? Because that's the question generally students are asking. Center of mass and center of gravity, will it be same always? Center of mass and center of gravity. So can anyone think and give answer? Center of mass, center of gravity will be same or different?
So I guess it would be different, sir.
Yes. What is center of gravity?
So the pull of the gravity by on the body, sir.
I didn't get. What is that? What you told?
So the pull of the gravity on the body.
Again, I didn't get. What you're telling?
Sir, like a body is standing here and the gravity that is pulling on the body, the gravitational force that is.
So object should be compulsory at rest for defining center of gravity.
No, sir, it can be moving also, sir.
Yes. So center of gravity, we can say the point at which gravitational force is acting. Point at which gravitational force is acting. Now, the point at which gravitational force is acting can be a center of mass point also. Can be a center of mass, but not necessarily it will be always same. So that's the point you have to understand, right? In which case it will be different. In which case it will be different. Suppose there is a very tall building. Very tall building. Okay. How much maximum we can have that floors in a building? How many it is in Pune? 3?
Sir, largest I have seen like 10, sir.
Huh?
Highest. 10,
How
sir.
much?
Highest 10, sir, right now that I have seen.
10.
Yes, sir.
Thane and Mumbai, how many are there? Here also in Chennai also. Let's take, okay, 100 floors. Okay. 100 floors are there. Now the problem in this type of building is center of mass is always at the geometrical center, assuming that mass is uniformly distributed throughout the floors. So center of mass will come at exactly at the center. So here will be center of mass. But the problem is acceleration due to gravity. Now as we go up, acceleration due to gravity decreases. So it means this portion, half portion, the center of gravitational force will be less. Gravitational force will be less. Why gravitational force will be less? We know what is the G value. G is equal to Gm by R square. Where R is the distance. So as the distance increases from center of mass of Earth, this is ME, mass of Earth, then G value decreases. Right? And there is one more formula. G is equal to G naught 1 minus 2H by R. Assuming H is negligible. In that case also, if H is more, G will be less. These things we'll discuss in gravitation topic. So the main idea is gravitational force will be less for the top portion. Gravitational force will be more here. Okay. Gravitational force will be more here. So in this case, if gravitational force is more here, then at this point, suppose we'll take individual blocks, first half and second half. Then if we have here, let's take M2G and here we have M1G. M1G is more. So slightly, if these 2 points if you'll consider, then center of gravity will come here. So center of gravity will be below the center of mass. Because gravitational force is less in the upper portion. So overall, if we'll try to calculate where is we can assume that gravitational force is, then we resultant we can find somewhere below the center of mass. So in that case, center of gravity and center of mass will be different. So for a tall buildings, right, or something which is, let's take G variation is extensive in that body, then center of gravity and center of mass will be different. So center of gravity is compulsory the point at which gravitational force is acting. It can be center of mass also if the object is small. But for big object, particularly big vertical object, it will be different. Big horizontal object, it can be same. No problem in that. So these small point you should remember. Now here also you see what the joker is doing here. What's the science behind it? Tell me. Why is not falling? Its entire center of mass should pass through this point on the wire. On the wire. If it will not on the wire, he will fall. So what he is doing basically, why is hanging the weight here? He is hanging the weight so that the weight here at least can pull the center of mass on this line on the wire. So even some fluctuation is there from its side, at least this heavy weight can maintain it. Similarly, you'll see some persons, some will have that big rod in their hand and they will walk onto the rope, right? They will walk on the rope. How they are walking it? Tell me. Why they need the rod basically?
Balance
What
the
they-
center of mass.
yes. So again, what they're trying to do it? They are trying to maintain their center of mass on this rope. If the center of mass is falling on the rope, no problem. If the center of mass will not fall on the rope of together means the person as well as the this part of rod or whatever stick, whatever they are taking, right? If it's not falling, the person will fall. So to balance somewhat, you will see when they are imbalancing themselves, they'll try to adjust this rod, right? So that the center of mass will come into that. So again, the logic is same. So these are the example of center of mass. Similarly here, can anyone explain what is this? The center of mass should not touch here. This one, this is what we discussed. See, the person is balancing the weight using this. So this is the example of center of mass. Okay. So any doubt, anyone in this? Okay. So this is enough example, I believe. Let's talk about now center of mass calculation. Center of mass calculation. What is the center of mass calculation? So it's very simple. For any two objects, let's talk about any two objects. Because whatever we'll talk about two objects, it is valid for multiple object also. And these are the point object. This is M1, this is M2. These are the point masses. What is meaning of point mass? How we'll say it is a point mass? How will say it is a point mass? Tell me. So the point mass is with respect to distance. Suppose the distance between them is d, right? Distance between them is d. If the distance between them is d and d is very high with respect to the dimension of M1 and M2, then M1 and M2 will start behaving like a point mass. So if the dimension of M1 and M2 is negligible, then it will start behaving like point mass, right? Can a building be a point mass? Can a building act as a point mass? So answer is yes, provided the other building what we are taking for calculation of this center of mass is just take 10,000 kilometers away, very far. So when we talk about very far, 10,000 kilometers away, this building dimension will be negligible, right? So in that case, we can assume this to be M1 and M2. So remember, this formula is applicable for point masses. Now, generally, what student think is point mass means it will be a point which is having a mass, not necessary. It is not related with point. Point or any line or anything is always relative. When we say D is very, very high, it will start behaving like a point mass. So we can apply this formula for any object provided distance between two objects is very high. So we have here M1, we have here M2. Okay. Distance between them is D. Distance between them is D. We want the center of mass. Very simple. Center of mass is basically a location of the point where entire mass is supposed to be concentrated. So instead of M1 and M2 separately, we have to find a point where we can assume that M1 and M2 is concentrated, supposed to be concentrated. Again, I'm saying, not necessary it will be there. If we'll try to go at that point and try to find where is M1 and M2, it will not be there. Nothing will be there. It's a hypothetical concept, center of mass, right? So M1 and M2 will be there. So what will assume this M1? M1 is 0, 0. M1 is 0, 0, right? M2 will be D, 0. Let's take this x-axis. Because coordinate we have to define, because coordinate is the location. Any coordinate is location. We want to calculate this one. So what we'll do? XCM. What the formula will apply? XCM. M1 x1. This formula we have to apply. M1 x1 plus M2 x2 divided by M1 plus M2. This formula of center of mass we should apply. M1 x1 plus M2 x2 divided by M1 plus M2. So center of mass calculation for two objects M1 and M2, which are at a distance of d apart, will be M1 x1 plus M2 x2 divided by M1 plus M2. Now how much is x1? What is the x1 value? X1 value is 0. Okay. What will be x2? X2 is d divided by M1 plus M2. So what will be the formula? M2d divided by M1 plus M2. M2d divided by M1 plus M2. From which point? From M1. So center of mass will be somewhere here. Remember, I am pointing it like a point, but it is a hypothetical point. So center of mass will be here. At what distance from here? At a distance of M2d divided by M1 plus M2. So center of mass will be located from M1. From M1. M2d divided by M1 plus M2. Now suppose we are interested in this quantity. How much this quantity will be? Total is d. So can we say this quantity will be d minus M2d divided by M1 plus M2, right? Which will be equal to how much? That will be equal to then M1d divided by M1 plus. Okay. So it will be M1d divided by M1 plus M2. So we can say distance of center of mass from M2 is M1d divided by M1 plus M2. I'll just again redraw it here so that clarity will be there. This is as a formula you have to remember. Many questions are asked based on this. Center of mass will be somewhere here, M1 and M2. Center of mass distance from here will be M2d divided by M1 plus M2. Center of mass distance from here will be M1d divided by M1 plus M2. You can see here from M2 the distance is M1d divided by M1 plus M2. From M1 the distance is M2d divided by M1 plus M2. So any doubt in this? Anyone? Derivation is okay. This is how we calculate for two masses M1 and M2 center of mass. This is the method to calculate it. Center of mass. Okay. Any doubt? Anyone? Okay. Now, what we can say about the center of mass? Can anyone conclude? What we can say about the center of mass? Suppose we are interested in center of mass distance from M1 divided by center of mass distance from M2. How much this quantity will be? Can we say this quantity is M2d divided by M1 plus M2 divided by M1d divided by M1 plus M2, which will be equal to how much? How much this quantity will be? Can we say it will be M2 by M1? Can we say this quantity will be M2 by M1?
Yes, sir.
What we can conclude about center of mass then? What we can conclude about the center of mass here? What we can say? Can we say center of mass is a point here which is dividing line joining M1 and M2 in the inverse ratio of their masses? Center of mass is a point which is dividing line joining M1, M2 internally in the ratio of in the inverse ratio of their masses, M2 by M1. So XCM, center of mass distance from M1 divided by center of mass distance from M2 is equal to M2 by M1. Okay. So any doubt in this? This formula you have to remember, because in this we have given even the value of distance also. And after cancelling d divided by M1 plus M2, we can write this one. Okay. So any doubt in this center of mass calculation? Any difficulty? Video will be available. Okay. I'll send you the link also. So you can again watch it. No problem. I'll put in the Facebook so that you can see it. Okay, so let's discuss further. Let's discuss further about this. Okay, so coming back to the basic formula, what the basic formula? XCM is equal to M1x1 plus M2x2 divided by M1 plus M2, right? This is a basic formula for center of mass. Now for the timing, let's put here M1 plus M2. So we can write M1 plus M2 into XCM is equal to M1x1 plus M2x2. Okay, can we write like this? Can we write like this? Any doubt, anyone in this? Can we write like this? Any difficulty? Can we write like this then? Can we differentiate it? Remember, XCM is nothing but the distance. dxcm by dt is equal to M1 dx1 by dt plus M2 dx2 by dt. Right? From here, what we can write? M1 plus M2 dxcm by dt. What is dxcm by dt? Can we say it is VCM? And can we say this is M1 V1 plus M2 V2? So in fact, that gives a new formula for us. M1 plus M2 into VCM is equal to M1 V1 plus M2 V2. Okay. M1 V1 plus M2 V2. So M1 plus M2 into VCM is M1 V1 plus M2 V2. What is meaning of that? What is M1 plus M2 into VCM? Can we say this is the momentum of center of mass? What is the mass of center of mass? Mass of center of mass is M1 plus M2. If you multiply M1 plus M2 into VCM, what it will give us? Momentum of center of mass is equal to momentum of the first particle plus momentum of the second particle. Because it's a vector quantity, I'll put the arrow also. Because V1 and V2, we have to take proper direction. And then we are. How we can define the center of mass now? What is the other definition of center of mass? Can we say that center of mass is a hypothetical point, momentum of which is equal to sum of momenta of the individual particles? Center of mass is a hypothetical point for which momentum is equal to sum of momenta of individual particles. So PCM will be P1 plus P2. Center of mass is a hypothetical point for which momentum is equal to sum of momenta of individual particles. Now this definition is clear. So this way also we can define center of mass. See, we are seeing center of mass from different angle. Different angle we are seeing. Different quantity wise we are seeing it. So this is also momentum wise we can see. Okay. Now related with this, one good question is there. Suppose there are two objects. Suppose there are two objects and they are moving. They are moving. Can we say that center of mass can be at rest? Not necessary at rest, can be at rest. If two objects are moving, if M1 and M2 are moving, right? M1 and M2 are moving, but center of mass is at rest. Will it be possible in any scenario?
Yes, sir.
Yeah, give some example.
Sir, if the M1 and M2 are at a constant distance, sir.
Okay, so constant distance, how they are moving then? Suppose they are at 100-meter constant distance. Then how they are moving? They are also at rest, na? Question is, if they are moving, M1 and M2 are moving, can we say center of mass is at rest? Will it be possible the center of mass to be at rest? Even if individual particles are moving, even if M1 and M2 are moving, center of mass is at rest. Can we say like that? Will it be possible?
Sir, when we consider the wheels in our vehicles, they are
When we again, when we consider
the wheels in our vehicles, sir, they are at a fixed distance. And
okay, let's do one thing. Let's not talk about rotation for the timing. It will confuse you more because rotation we have to still do. Can we give some example from translational motion without involving rotation? Remember here, we are not talking about the rotational center of mass concept is different from rotation. It is more related with translational motion if you'll see the previous thing. So translational motion we are talking, V1 and V2. We are not talking about omega 1, omega 2. Translational motion, it is possible. It's very simple. Yes, it is possible. How it is possible? Suppose there is a 5 kg object. This is moving with 10 meter per second this side. This is 10 kg object moving this side with 5 meter per second. Right? What is the momentum for this? Suppose this direction will take positive. Can we say this is having plus 50 momentum? What is the momentum for this? Minus 50 momentum. Plus 50 and minus 50 will be how much? 0. The total momentum will be how much? Total momentum will be P1 plus 50 minus 50, 0. So momentum center of mass is how much? 0. This is what the recoil is. See, this is what the recoil is. When someone is firing a gun, right? When someone is firing a gun, what is the recoil basically? Recoil is based on this concept. If someone is firing a gun, bullet is moving. Now, if the bullet is moving, what the gun will do? Gun will recoil in the backward direction because the overall momentum is 0. No force is applied on the center of mass. So if bullet is moving in the forward direction, gun will move in the backward direction. So this is what the recoil is. Right? It is based on this concept only. The total momentum of the center of mass has to be 0 initially as well as finally because there is no force applied. Right? So if bullet is moving in the forward direction with, let's take 10 meter per second, 5 kg, suppose, okay, it will mass will less generally, but suppose for example, then the plus momentum in one direction will be cancelled by negative momentum. So the gun has to move in backward direction. There is no other option. So recoil is the best concept to understand that even if individual particles are moving, center of mass will be at rest. Okay. So any difficulty in this concept? M1 plus M2 into VCM is M1 V1 plus M2 V2. Again, I'm recapping this point. Center of mass is a hypothetical point for which the entire momentum is equal to sum of momenta of the individual particle. Okay. So any difficulty, anyone in this? Okay. So let's clear this one. Then again, based on this, one more logic is there. That is what we have to understand. Center of mass is a very interesting topic. See, now we discussed M1 V1 or M1 plus M2 into VCM, okay, is equal to M1 V1 plus M2 V2, right? Now let's differentiate it one more time. So we'll write M1 plus M2 into dVCM by dt is equal to M1 dV1 by dt plus M2 dV2 by dt, okay? Or we can write M1 plus M2. What is dVCM by dt? Differentiation of velocity. What it will give us? It will give us acceleration. So M1 plus M2 into ACM will be equal to M1 A1 plus M2 A2. Right? It's a vector quantity, so I'm putting a vector here. Now what is M1 plus M2 into ACM? Tell me, what is M1 plus M2 into ACM? Can we say it is a net external force, mass into acceleration? So what we can say? F net center of mass is equal to F net M1 plus F net M2. Right? So now we have a third or fourth way to define center of mass. How we can define center of mass? Center of mass is a hypothetical point at which, on which net external force is nothing but vector sum of force acting on M1 and M2. So if we'll add the forces, vector addition of M1 and M2, then the net force will come. That net force is nothing but force acting on center of mass also, right? So this way also we can define center of mass. Any doubt, anyone in this? These are the points which are very, very important, and if you'll understand this, it will help you in solving all the numericals, which I'm going to give you now, those numericals. Okay. So any doubt, any difficulty, anyone in this one? Send me in the chat box also. Okay. With this theory is over for center of mass. Now we'll go towards numerical. Okay.